Right. Today I want to talk about operating systems. And I'm not talking about Microsoft or Macintosh or Linux or whatever you happen to be running at home or whatever your favorite OS is. No, I'm talking about firearms. Oh yes. And it doesn't even really matter what one may think about firearms in a political or social sense to find it absolutely intriguing to discover how they work and to be enlightened by what you may learn. So let's explore it. Right, so let's dive into this. For single shot firearms, it's pretty self-explanatory. You fire, you put a new round in, you reactuate the firing mechanism, and then you shoot again. Pretty effective, but also pretty boring. Now, repeating firearms make it possible to fire one round after the other. This is possible because of a certain sequence of stuff that happens, commonly referred to as the cycle of operations. Essentially, this is a sequence of different actions that take place within the firearm, and they could be powered by human power, by cranking a lever or working a pump, or they could be powered by the excess energy generated by the detonation of the powders of the shell. Either way, they make it possible to shoot round after round. I don't know what else to say about it than that, so I probably ought to explain it. Going to be going over the components of the cycle of operations in context of these operating systems. Bolt action, which is a bolt that you manipulate with your own man or woman power to get the cycle of operations to work. Blowback operation, which uses the expanding gases produced by a detonating round to get the cycle of operations to work. Recoil operation, which is taking the excess and reactive kinetic energy produced by the bullet flying out of the barrel to actuate the cycle of operations. And gas operation, which uses, similar to blowback, expanding gases to get everything to work, but usually in a little bit more sophisticated kind of way. You'll learn all about it right now. First step is firing. The second step is unlocking. The third step is extracting. The fourth step is ejecting. The fifth step is cocking. The sixth step is feeding. 7 is chambering. And last is locking. So here we have a tilting barrel recoil operated pistol, and the whole concept of operation behind this is as a bullet travels out of the barrel, an equal and opposite reaction force pushes back on the barrel. It pushes back on the barrel just like that. The bullet travels out and the barrel gets pushed back by the reactive forces, and this happens so quickly that the inertia carries the slide back and cycles the operation. So when this weapon fires, the trigger releases a catching mechanism on this little notch right here, and this is the striker. And when you pull the trigger, it's released, and then the firing pin springs forward and strikes the primer on the round. As the round leaves the barrel gets pushed back and causes the tilting barrel mechanism to unlock the firearm. This piece right here is the extractor, and this little, you can't really see it, but a hook-like mechanism will catch on the rim of the round, and as the slide moves back, will pull the round out of the chamber, extracting it. This little tab right here is the extractor, and as the slide moves backwards with the round seated on the bolt face, that extractor catches on the back side of the round and flings it out of the side. This is the striker catching lug on the striker itself. And this little tab right here has a hook on it, and when the weapon's fired and the slide comes back, it'll pop up and catch on this hook, cocking it. And when the slide is in the fully rear position and there's a magazine inserted, and the slide begins to come forward again, it strips around off the face of the magazine and begins to feed it into the chamber. And once a round is fully chambered and the bolt face is met up with the chamber, then it could then again lock into position and the cycle is ready to be repeated. That's recoil operation. You take some of the excess kinetic energy created by the detonation of the round and you convert that into an energy source to work the cycle of operations. It's got a couple of drawbacks though. It's all about weights and balances. The bigger you want your bullet to be, the bigger the whole of the reciprocating parts have to be. So in a handgun, if you want to up your caliber or up your cartridge size, then you gotta have, in general, a bigger handgun. And for really big recoil operated weapons like the Browning M2, you have an absolutely massive bolt that reciprocates to make everything work. And there's a way around this if you still want an automatic firearm, and that's just to simply use the expanding gases that are generated once the round goes off to work the cycle of operations. Enter blowback operation. In blowback operation, the round goes off, gases expand, and in a handgun, it just forces the slide back and voila. Blowback operation works particularly well in pistols because it offers a couple of advantages. One, it actually simplifies the cycle of operation by eliminating the need to lock and unlock. The slide just rests on the barrel, and whenever the round goes off, the gas forces it back and it comes back in. Also, since there's no need to lock the barrel to the slide, it could just be a fixed barrel, it doesn't move. And by fixing it in place, you could make an inherently more accurate weapon, which is pretty cool. Another advantage that blowback operation could offer in a handgun is that you don't necessarily need to balance the weight of the slide with the weight and power of your cartridge. This is offsetted by the spring tension, so you could have a smaller slide and you could make up for that with the tension of the recoil spring. But there comes a certain point to where you make the slide so small that the recoil spring tension becomes so hard that the weapon could be difficult to manipulate. So there's a potential disadvantage there at the same time.
So here we have a blowback operated pistol with a fixed barrel. And as you can see, a lot of the components of this weapon are the same as they were with the larger recoil operated pistol. There's the ejector, pretty much the exact same mechanism. And with the exception of locking and unlocking, the cycle of operations is pretty much executed by the same mechanics in this pistol due to its design. Because the fixed barrel rests against the slide, the gases push the slide back. There's no need to lock the two together to ensure the transfer of any energy.
So that's blowback operation. It's simple, it's effective, but generally speaking, it's limited to lower power cartridges. And this is because higher power cartridges, such as rifle cartridges, once they detonate, the gas pressure levels in the chamber are so high that if you were to release them right away, then you could either damage the components of the weapon or even sustain injury. So when it comes to higher power cartridges, you need a more sophisticated system to channelize the gases to work the cycle of operations. Gas operation makes cycling larger rounds, or more powerful rounds that is, possible by allowing the chamber to remain sealed shut until gases have reached a safe level for everything to reciprocate in the cycle of operations to move on. This is done by diverting the gases to a different point in the weapon, allowing a certain amount of time to pass, the gas levels to die down, and then everything can reciprocate and everything's happy. So here we have a shoulder-fired gas-operated rifle, and the cycle of operations for this is in the exact same order. And in contrast to the pistol, which has a reciprocating slide, the upper receiver of this rifle is fixed and it just has a reciprocating bolt. So as you can see, the hammer falls on the firing pin, the round would detonate, sending the gases up the barrel along with the bullet itself. And then right here, gases are vented upward onto a rod, which then pushes back on the bolt, forces it backward, and as it slides back, the bolt rotates to unlock, and then everything just cycles over again. In contrast to a recoil operated pistol where the barrel locking to the slide ensures the maximum transfer of kinetic energy from the barrel to the slide so it can reciprocate, locking in a gas-operated rifle just ensures that the chamber is going to remain closed while the gas pressures inside the barrel are super high. This spring right here is what allows the bolt to go back into position. This rod right here is what the gases come up and push on, so they'll push that back and then it'll spring out really quick, and then inertia will carry the bolt back. Once the gases reach these little vent holes right here, then they're released into the atmosphere. The gas levels are kept safe by allowing some to escape with the bullet out of the end of the barrel, and then once they're used to direct the gas rod to the rear, then they're released into the atmosphere. So essentially, the residual gas pressure at the chamber by the time the gases are diverted to this point are extremely low, and it keeps the weapon safe to operate. But there's a couple of inefficiencies. One is all the moving parts makes there a certain proneness for inaccuracy. While a gas-operated rifle can be accurate, it'll never truly be as accurate as a simpler design. And at the same time, since some of the gases are used to operate the system, there's also a slight loss of power. With a bolt-action system, you eliminate those two inefficiencies for maximum accuracy and muzzle velocity.
So here we have a bolt-action rifle, if you couldn't already tell. And what's sweet about this thing is you could practically see the entire cycle of operations going down without even disassembling the weapon. Firing, unlocking, extracting, ejecting, cocking, feeding, chambering, and locking again. And you're ready to fire again. In a bolt-action rifle, all of the gases can be put behind a bullet to produce maximum muzzle velocity, which in turn results in enhanced ballistic performance. And due to the simplicity of the design, you can make these things with a great deal of precision, which is conducive to excellent accuracy.
Well, you sure don't need me to tell you that there's more than 4 different kinds of guns on this planet, but what most modern weapons do have in common is this cycle of operations. And I hope learning about the ones that I showed you today kind of gave you some insight on how repeating guns work in general. I hope you're inspired to learn something new and that you thought what you learned here was pretty cool. Thanks. Don't let me down and have a good one. See ya.